A series of experiments is carried out between C and D. Use the data obtained. The rate equation is given below. In one experiment, the initial rate, so the initial rate is 3.1 times 10 to the minus 3, and C, which is this one, is 0.48, and D, which is this one, is 0.23. Calculate the value for the rate constant. So we need to rearrange this to say K equals, so K equals rate divided by concentration of C times concentration of D. Then we're going to put the numbers in. K equals 3.1 times 10 to the minus 3 divided by 0.48 times 0.23. We're going to type that on our calculator, and it's going to come out to be 2.8 times 10 to the minus 2, or 2.81 times 10 to the minus 2 if we give three significant figures. I mean, they've only given all their numbers to two significant figures, so we could just write 2.8 or 0.028 if you don't want it in standard form. Now we have to find the units. So remembering that the units of rate were in moles per decimetre cubed per second, and each one of their concentrations were in moles per decimetre cubed, then what we've ended up doing is losing some of our moles per decimetre cubed, and we've ended up with one lot of moles on the bottom line, so moles to the minus 1, dm cubed, because the minus 3 becomes positive 3, and the second to the minus 1 always stays with our rate equations. Then the question continues, and it's showing us the Arrhenius equation, and it wants us to calculate a value for the kinetic energy in kilojoules per mole. This is the kinetic energy here. It's giving us a value for LNA, so it's already the LNA value, which is this value here. It's given us R, but R is in joules, and we need our answer in kilojoules. That's going to be important at the end. And we're using our answer from part 3.1, which was, remember, was that K equals 0.28. Oops, 0.028 even. So, ln of 0.028 equals minus EA divided by 8.31 times 25 degrees C is add 298 Kelvin plus 16.9. So the first thing I'm going to do is I'm going to ln 0.028. I'm going to get minus 3.58. I'm going to minus the 16.9, and that's going to be keeping the fraction at the moment because I can't multiply that out until I've evaluated the additions. So minus 3.58 minus 16.9 is minus 20.5 equals minus EA over 8.31 times 298. So now I'm going to multiply out the bottom line. So times by 8.31 and times by 298. And I'm getting minus 5716. But that means that EA equals 5716 because I just lose the minus sign. But this, remember, is in joules per mole because R was in joules and it wants our answer in kilojoules. So we're going to divide by 1,000, which gives us 50.7 kilojoules. But given that the data was some of it 2, some of it 3, so you could just write 50.7 or you could write 50.7 kilojoules per mole.